What if everything you thought you knew about the universe was just the tip of the iceberg? Imagine a reality where the stars above hold secrets so strange, so unsettling, that they could rewrite everything we believe about existence itself. From the eerie silence of the cosmos to the chilling possibility that we might be living in a simulation, the universe is full of mysteries that defy explanation. Today, we're diving into 25 of the creepiest theories about the universe, each one more mind-bending than the last. These are not just ideas pulled from science fiction. They are real, scientifically grounded concepts that challenge our understanding of reality, time, and even our own existence. So, buckle up and prepare for a journey through the unknown, where the rules of physics twist, the fabric of space unravels, and the very nature of reality is called into question. Stay with us, because by the end of this video, you might never look at the night sky the same way again. Now turning to the first theory, we explore the simulation hypothesis, a concept that suggests our universe might not be as real as we think. Imagine for a moment that everything around you, from the stars in the sky to the ground beneath your feet, is part of an incredibly advanced simulation created by a higher intelligence. This idea, once confined to the realms of science fiction, has gained serious traction among philosophers and scientists alike. One of the most prominent voices supporting this theory is Nick Bostrom, a philosopher who argues that future civilizations with immense computing power might choose to run simulations of their ancestors. If this is true, the odds are staggeringly high that we are living in one of those simulations rather than the original reality. Elon Musk, the tech entrepreneur, has also famously expressed his belief in this theory, stating that the chances of us living in base reality are 1 in billions. The implications are both fascinating and unsettling. If our universe is a simulation, it challenges everything we know about existence, free will, and the nature of reality itself. Are our choices truly our own, or are they pre-programmed by the creators of this simulation? Could the laws of physics be nothing more than lines of code? This theory forces us to confront the eerie possibility that our entire reality might be an illusion, a carefully crafted construct designed by beings far beyond our comprehension. As we ponder these questions, the simulation hypothesis invites us to question not just the universe, but the very fabric of our own existence. Now shifting our focus to the next unsettling theory, we delve into the Boltzmann Brain Paradox, a concept that challenges our understanding of consciousness and the very nature of existence. Imagine for a moment that your mind, your thoughts, and your sense of self are not the result of billions of years of evolution, but rather a random fluctuation in the vast, chaotic expanse of the universe. This is the core idea behind Boltzmann brains, named after the physicist Ludwig Boltzmann, who explored the relationship between entropy and the universe. According to this theory, in a universe that lasts long enough, random fluctuations in energy could spontaneously create self-aware entities, like human brains, completely by chance. These Boltzmann brains would exist for only a fleeting moment, experiencing a brief flash of consciousness before dissolving back into the void. The implications are deeply unsettling. If this theory holds true, it suggests that our consciousness might not be the product of a grand, purposeful process like evolution, but rather a rare and temporary accident in an otherwise indifferent cosmos. What does this mean for our understanding of reality? If our minds are just random blips in the universe, how can we trust our perceptions or the conclusions we draw about the world around us? This paradox also ties into the concept of entropy, the measure of disorder in the universe. Over unimaginable spans of time, entropy tends to increase, leading to a universe that becomes more chaotic and less structured. In such a universe, the spontaneous creation of a Boltzmann brain becomes more likely than the formation of an entire, ordered civilization like ours. This raises eerie questions about the nature of existence itself. Are we the result of a meaningful evolutionary process, or are we simply a cosmic accident, destined to fade away as quickly as we appeared? As we grapple with these questions, the Boltzmann Brain Paradox forces us to confront the fragility of our consciousness and the unsettling possibility that our existence might be far more random and far less significant than we ever imagined. Now turning to another chilling theory, we explore the Great Filter, a concept deeply tied to the Fermi Paradox. The Fermi Paradox asks a simple yet haunting question. If the universe is so vast and filled with countless stars and planets, why haven't we encountered any signs of intelligent alien life? One possible answer lies in the Great Filter theory, which suggests that advanced civilizations inevitably face some kind of catastrophic event that prevents them from reaching the stars. This filter could be a natural or self-inflicted barrier that wipes out civilizations before they can expand beyond their own planet. For humanity, this raises a terrifying possibility. Are we approaching our own Great Filter? Could climate change, nuclear war, pandemics, or some other existential threat be the event that halts our progress as a species? The idea is both sobering and urgent. If the Great Filter lies ahead of us, it means we are on the brink of a potential extinction-level event. But there's another, even more unsettling possibility. What if the Great Filter is already behind us? If so, it would mean that the emergence of intelligent life is so rare and improbable that we might truly be alone in the universe. Either scenario forces us to confront the fragility of our existence and the responsibility we have to safeguard our future. As we ponder these questions, the Great Filter theory serves as a stark reminder of the challenges we face, not just as a species, but as a civilization striving to survive in a vast and indifferent cosmos. Now shifting our gaze to the shadows of the cosmos, we encounter the dark forest hypothesis, a theory that paints a chilling picture of the universe as a place of silence and secrecy. Imagine a vast, dark forest where every civilization is a hunter, hiding in the shadows, afraid to make a sound. This theory suggests that alien civilizations remain silent not because they don't exist, but because they are deliberately avoiding detection. Why? Because in a universe filled with unknown threats, revealing yourself could mean inviting destruction. The dark forest hypothesis draws eerie parallels to survival strategies in nature, where predators and prey alike stay hidden to avoid becoming targets. In this cosmic forest, every civilization is both hunter and hunted, and the stakes are unimaginably high. The implications are profound. If this theory holds true, it means that the silence we hear from the universe isn't a sign of emptiness but of caution. It suggests that any attempt to reach out to extraterrestrial life could be met with hostility or worse, annihilation. This raises a haunting question. Should we continue our search for alien life, or is the risk too great? The dark forest hypothesis forces us to confront the possibility that the universe is not a place of open communication and cooperation, but a dangerous arena where survival depends on staying hidden. As we ponder this theory, it serves as a stark reminder of the delicate balance between curiosity and caution in our quest to understand the cosmos. Now turning to the cosmic dance of creation and destruction, we arrive at the Big Crunch theory, a chilling counterpart to the Big Bang. Imagine the universe not as an ever-expanding void, but as a colossal pendulum swinging from expansion to contraction. The Big Crunch suggests that one day the universe's expansion will slow, halt, and then reverse, pulling everything, galaxies, stars, planets, and even atoms, back into an infinitely dense point known as a singularity. This isn't just the end of the universe as we know it, it's the collapse of everything into a single, unimaginably small point of infinite density. The Big Crunch is the ultimate cosmic reset button, a terrifying mirror image of the Big Bang. Where the Big Bang marked the beginning of everything, the Big Crunch would mark its end, or perhaps its rebirth. This cyclical view of the universe raises profound questions about time and existence. If the universe collapses and then explodes again in another Big Bang, does time itself loop endlessly? Are we living in just one iteration of an infinite cycle, destined to repeat the same cosmic story over and over? The Big Crunch forces us to confront the possibility that our universe is not a one-time event, but part of an eternal cycle of birth, death, and rebirth. It challenges our understanding of time as a linear progression and suggests that existence itself might be a never-ending loop. As we ponder this theory, it leaves us with a haunting question. If the universe is destined to collapse, what does that mean for the meaning of our lives, our memories, and our place in the cosmos? The Big Crunch is a reminder that the universe is not just vast and mysterious, but also fragile and fleeting, a cosmic dance that could end as suddenly as it began. Now shifting our gaze to a far more chilling cosmic fate, we arrive at the heat death of the universe. Unlike the dramatic collapse of the Big Crunch, this theory paints a picture of a slow, silent, and inevitable decay. Imagine the universe not as a pendulum swinging between creation and destruction, but as a candle burning down to its final flicker. The heat death theory suggests that as the universe continues to expand, it will eventually reach a state of maximum entropy, where all energy is evenly distributed and no usable energy remains. Stars will burn out, galaxies will drift apart, and the cosmos will become a cold, dark, and lifeless void. This isn't a fiery end or a dramatic collapse, it's a gradual fading into nothingness. The universe, once teeming with light and life, will become a graveyard of scattered particles, too far apart to interact, too cold to sustain any form of activity. The heat death is the ultimate expression of entropy, the natural tendency of systems to move toward disorder. It's a future where time loses all meaning as nothing changes, nothing happens, and nothing remains to mark the passage of time. The eerie silence of this scenario is perhaps its most unsettling aspect. No stars will shine, no planets will orbit, and no life will stir. The universe will simply exist in a state of perfect stillness, a frozen expanse where even the concept of existence becomes meaningless. This theory forces us to confront the idea that the universe is not just finite, but also destined for a cold, quiet end. It challenges our notions of progress and purpose, suggesting that even the grandest cosmic structures are temporary, fleeting, and ultimately doomed to fade away. As we ponder the heat death, we're left with a haunting question. If the universe is destined for such a bleak and silent end, what does that mean for the significance of our lives, our achievements, and our place in the cosmos? The heat death is a stark reminder that the universe, for all its beauty and complexity, is also fragile and impermanent, a fleeting moment in the vast expanse of eternity. Now stepping into a realm where reality itself splinters into infinite possibilities, we encounter the multiverse theory. This idea suggests that our universe is just one of countless others, each with its own unique set of physical laws, histories, and even versions of ourselves. Picture a cosmic tapestry woven with threads of alternate realities where every decision you've ever made or could have made spins off into a new universe. Did you take that job offer or turn it down? In one universe, you're a CEO. In another, you're an artist. The implications are staggering, not just for science, but for our understanding of identity and free will. Are we truly the authors of our own lives, or are we merely one version of ourselves, living out a single thread in an infinite web of possibilities? The scientific basis for the multiverse stems from theories like quantum mechanics and cosmic inflation. In quantum mechanics, particles exist in multiple states until observed, leading some to speculate that every possible outcome of an event actually occurs but in separate universes. Meanwhile, cosmic inflation suggests that our universe is just one bubble in a vast, ever-expanding foam of universes, each with its own unique properties. These ideas, while still theoretical, challenge our perception of reality and force us to reconsider what it means to exist. But the multiverse isn't just a scientific curiosity, it's a philosophical minefield. If infinite versions of us exist, does that diminish the significance of our choices? Are we truly unique, or just one variation in an endless sea of possibilities? And what does it mean for our sense of self if somewhere out there, another version of us is living a completely different life? The multiverse theory doesn't just expand our understanding of the cosmos. It forces us to confront profound questions about who we are and what it means to be human. As we ponder the infinite possibilities of the multiverse, we're left with a haunting thought. In a reality where everything that can happen does happen, what does it mean to truly exist? Now shifting our gaze to one of the most perplexing mysteries in the cosmos, we arrive at the black hole information paradox. Imagine throwing a book into a fire. The pages burn, the ink fades, but the information, the words, the story isn't truly lost. It's just transformed into ash and smoke. But what if you threw that book into a black hole? According to our current understanding of physics, the information inside that book might vanish forever, and that's a problem. This paradox stems from the work of Stephen Hawking, who discovered that black holes aren't entirely black. They emit radiation, now famously known as Hawking radiation, which causes them to slowly evaporate over time. But here's the catch: Hawking radiation appears to be random, carrying no information about what fell into the black hole. This raises a chilling question: what happens to all the information about the matter and energy that gets sucked in? If it's truly lost, it violates one of the most fundamental principles of quantum mechanics: that information cannot be destroyed. The implications are staggering. If information can disappear into a black hole, it would mean our understanding of the universe's most basic laws is incomplete or even wrong. Some scientists suggest that the information might be encoded in the Hawking radiation, but we don't yet know how. Others propose that it could be stored on the black hole's event horizon, the point of no return, in a kind of cosmic hologram. But the truth remains elusive, leaving us with an eerie possibility. That black holes might be the ultimate cosmic shredders, erasing information from existence and leaving behind a universe where the past is unknowable. As we grapple with this paradox, we're forced to confront the limits of our knowledge. Are black holes the ultimate mystery, or do they hold the key to unlocking deeper truths about the universe? The black hole information paradox doesn't just challenge our understanding of physics, it forces us to question the very nature of reality itself. And as we ponder this cosmic enigma, one thing is certain: the universe is far stranger and far more mysterious than we ever imagined. Now stepping into a realm that feels like science fiction but is grounded in cutting-edge physics, we encounter the holographic principle. This theory proposes a startling idea: our three-dimensional universe, with all its depth and complexity, might actually be a two-dimensional projection of information encoded on a distant boundary. Think of it like a hologram, a flat surface that creates the illusion of depth. But in this case, the hologram is the entire cosmos, and the flat surface is a boundary we can't even see. The roots of this theory lie in the study of black holes. Scientists discovered that the information about everything that falls into a black hole isn't lost but is instead encoded on its event horizon, the point of no return. This led to the idea that the universe itself might operate in a similar way, with all the information about our reality stored on a two-dimensional surface at its edge. It's as if the universe is a cosmic movie, and the screen it's projected on is far simpler than the story it tells. The implications are mind-bending. If the holographic principle is true, it means that everything we experience, the stars, the planets, even our own thoughts, might just be a projection. Space and time, the very fabric of reality, could be illusions created by this underlying two-dimensional code. This challenges our most basic assumptions about existence and raises profound questions. Are we living in a simulation? Is reality just a shadow of something far more fundamental? There's even scientific evidence supporting this idea. Studies of black holes and quantum gravity suggest that the mathematics of the holographic principle could explain some of the universe's deepest mysteries, like how gravity works on the smallest scales. It's a theory that bridges the gap between quantum mechanics and general relativity, two pillars of physics that have long seemed incompatible. As we grapple with the holographic principle, we're forced to rethink what it means to exist. Are we just characters in a cosmic hologram, or is there something more to the story? This theory doesn't just challenge our understanding of the universe, it invites us to imagine a reality where the boundaries of space and time are far more fluid than we ever thought possible. And as we explore this idea, one thing becomes clear: the universe is not only stranger than we imagine, but stranger than we can imagine. Now, shifting our gaze to one of the most perplexing mysteries of the cosmos, we revisit the Fermi paradox. Named after physicist Enrico Fermi, this paradox asks a simple yet haunting question. If the universe is so vast and filled with countless stars and planets, where is everyone? Given the high probability of extraterrestrial life, why haven't we detected any signs of intelligent civilizations? The eerie silence of the universe stands in stark contrast to the expectation that it should be teeming with life. One possible explanation is the grim idea of self-destruction. Advanced civilizations like our own might develop technologies powerful enough to destroy themselves, whether through nuclear war, environmental collapse, or other catastrophic means. If this is a common fate, it could explain why we haven't encountered other intelligent beings. They may have already vanished before reaching out to the stars. Another possibility is that intelligent life is far rarer than we think. While the universe is vast, the conditions necessary for life to evolve into complex, intelligent forms might be incredibly rare. Perhaps we are one of the few, or even the only, species to have reached this level of development. This idea, while humbling, also raises questions about our responsibility as a potentially unique civilization in the cosmos. Then there's the chilling notion that alien civilizations might be deliberately avoiding us. This could be due to fear, caution, or even a policy of non-interference. Imagine a universe where advanced species observe us from a distance, choosing not to make contact until we reach a certain level of maturity or technological advancement. This idea, often referred to as the zoo hypothesis, suggests that we might be living in a cosmic zoo, watched but not acknowledged. The implications of the Fermi paradox are deeply unsettling. If intelligent life is common but self-destructive, it paints a bleak picture of our own future. If it's rare, it underscores the fragility and preciousness of our existence. And if aliens are deliberately avoiding us, it forces us to confront the possibility that we are not yet ready to join the cosmic community. As we ponder these possibilities, the Fermi paradox challenges us to reflect on humanity's place in the universe. Are we alone, or are we simply not listening closely enough? The silence of the cosmos may hold answers we are not yet equipped to understand, but it also invites us to keep searching, to keep questioning, and to keep dreaming of what might lie beyond the stars. Now turning to a theory that feels like it's straight out of a science fiction novel, we explore the zoo hypothesis. This unsettling idea suggests that advanced alien civilizations might already be aware of us but choose to remain hidden, observing humanity from a distance. Imagine a cosmic zoo where we are the exhibits, watched but never acknowledged. The parallels to how humans study animals in zoos are eerie, raising profound ethical questions about observation, interference, and the nature of curiosity. Why would an advanced civilization choose to avoid contact? One possibility is that they are following a strict policy of non-interference, much like the prime directive in science fiction. They might believe that allowing a species to develop naturally without external influence is the most ethical approach. This could mean they are waiting for humanity to reach a certain level of technological or moral maturity before revealing themselves. But what if we never reach that point? Are we doomed to remain in the dark, unaware of the cosmic community around us? Another chilling aspect of the zoo hypothesis is the idea that we might be completely unaware of being observed. Advanced civilizations could have technologies far beyond our comprehension, allowing them to monitor us without detection. This raises the unsettling possibility that every moment of human history, our triumphs, our failures, our discoveries, has been witnessed by beings we cannot see or understand. It's a humbling thought, one that challenges our sense of uniqueness and control. The ethical implications of such behavior are profound. If aliens are indeed observing us, what responsibilities do they have toward us? Should they intervene in times of crisis, or is their role strictly to observe? And what does it say about humanity if we are seen as a species not yet ready for contact? These questions force us to confront our own limitations and the possibility that we are not as advanced as we like to believe. As we consider the zoo hypothesis, it invites us to reflect on our place in the universe. Are we alone, or are we simply being watched? The idea that we might be part of a grand cosmic experiment is both fascinating and unsettling. It challenges us to think beyond our own perspective and consider the possibility that we are not the only intelligent beings in the cosmos, just the ones who haven't yet been invited to the table. Now shifting our gaze to a theory that blurs the line between science and the surreal, we delve into the quantum immortality theory. This mind-bending concept suggests that your consciousness might never truly experience death. Instead, it continues to exist in alternate realities, even if you die in others. Imagine this: every time you face a life-threatening situation, your consciousness splits into a new reality where you survive, while another version of you ceases to exist. It's as if the universe ensures that you, or at least your awareness, live on indefinitely. At the heart of this theory lies the many worlds interpretation of quantum mechanics, which proposes that every possible outcome of a situation actually occurs, but in separate, branching universes. In one reality, you might narrowly escape a car accident, while in another, the outcome is tragically different. Quantum immortality takes this idea a step further, suggesting that your conscious experience will always follow the path where you survive, no matter how unlikely it seems. This raises profound questions about mortality and identity. Are we truly immortal in some sense, or is this just an illusion created by the branching nature of reality? The implications of this theory are both fascinating and unsettling. On one hand, it offers a strange kind of comfort, the idea that death might not be the end for your consciousness. On the other hand, it forces us to confront the possibility that we are living in just one of countless realities, each with its own version of us. What does this mean for our sense of self? Are we truly the same person across these infinite universes, or are we fragmented into countless variations, each with its own experiences and memories? This theory also challenges our understanding of free will. If every possible outcome exists in some universe, does that mean our choices are meaningless, or do they simply create new branches of reality? And what happens to the versions of us that don't survive? Do they simply cease to exist, or is there some form of continuity we can't comprehend? These questions push the boundaries of both science and philosophy, inviting us to rethink what it means to live, die, and exist. As we ponder the quantum immortality theory, it's impossible not to feel a mix of awe and unease. It's a reminder that the universe is far stranger than we often imagine, and that our understanding of reality is still in its infancy. Whether this theory offers a glimpse into the true nature of existence or simply a fascinating thought experiment, it leaves us with one undeniable truth: the cosmos is full of mysteries that challenge our very perception of life and death. Now shifting our focus to a theory that could rewrite the very fabric of existence, we explore the unsettling concept of the false vacuum collapse. Imagine our universe as a delicate bubble floating in a vast cosmic sea. For now, it seems stable, but what if this stability is just an illusion? This theory suggests that our universe exists in a metastable state, a precarious balance that could tip at any moment. If it does, the consequences would be catastrophic. A single quantum event could trigger a collapse into a lower energy vacuum, creating a bubble of destruction that expands at the speed of light, obliterating everything in its path. The science behind this theory is rooted in the behavior of quantum fields. In simple terms, the universe's current state is like a ball resting on a hilltop. It appears stable, but the slightest nudge could send it tumbling into a valley of lower energy. If this happens, the laws of physics as we know them would fundamentally change. Atoms, stars, planets, everything we see and know would cease to exist in their current form. The bubble of destruction would spread relentlessly, leaving nothing but a new, alien universe in its wake. What makes this theory so eerie is its unpredictability. Unlike other cosmic threats such as asteroid impacts or supernova, a false vacuum collapse could happen at any moment without warning. It's a reminder that the universe operates on scales and timelines far beyond human comprehension. One moment, everything could be normal. The next, the universe as we know it could vanish in an instant. This theory also raises profound questions about the nature of reality. If our universe is just one possible state among many, what does that mean for our existence? Are we living in a cosmic house of cards, waiting for the slightest breeze to bring it all crashing down? And if such a collapse were to occur, would there be any trace of our universe left, or would it be erased entirely as if it never existed? The false vacuum collapse is a chilling reminder of the fragility of existence. It challenges us to confront the possibility that the universe is far more volatile than we imagine, and that our understanding of reality is built on a foundation that could crumble at any moment. As we ponder this theory, we're left with a mix of awe and unease, marveling at the complexity of the cosmos while grappling with the unsettling idea that everything we know could vanish in the blink of an eye. Now turning to a concept that flips our understanding of cosmic phenomena on its head, we delve into the mysterious and unsettling white hole theory. Imagine a black hole, but in reverse, where instead of pulling everything in, it violently expels matter and energy into the universe. This is the essence of a white hole, a theoretical object that defies our conventional understanding of space and time. While black holes are known for their immense gravitational pull, white holes are thought to be their polar opposites, spewing out light, matter, and energy with such force that nothing can enter them. The idea of white holes emerges from the equations of general relativity, the same framework that predicts black holes. In fact, some scientists speculate that white holes could be the other end of a black hole, connected through a theoretical tunnel known as a wormhole. This raises the eerie possibility that black holes and white holes are two sides of the same cosmic coin, with matter and energy traveling through a hidden bridge in spacetime. If this is true, it could open the door to mind-bending concepts like time travel or even alternate universes. But here's where things get even stranger. Unlike black holes, which we've observed indirectly through their effects on surrounding matter, white holes remain purely theoretical. No direct evidence of their existence has ever been found, leading some to question whether they are real or just mathematical curiosities. Yet, the implications of white holes are too fascinating to ignore. If they do exist, they could challenge our understanding of the universe's structure, suggesting that space-time is far more interconnected and dynamic than we ever imagined. One of the most unsettling aspects of white holes is their potential role in the universe's life cycle. Some theories propose that white holes could be the remnants of ancient black holes, erupting after billions of years to release the matter and energy they once consumed. This would mean that the universe could be filled with hidden cosmic fountains, waiting to burst forth and reshape the cosmos in ways we can't yet comprehend. The white hole theory also raises profound questions about the nature of time. If black holes and white holes are connected, could they form a loop where time itself bends and folds? Could a white hole be a gateway to the past or a portal to another dimension? While these ideas remain speculative, they highlight the eerie and mysterious nature of the universe, reminding us that there's still so much we don't understand. As we explore the concept of white holes, we're left with a sense of wonder and unease. They challenge our perception of reality, suggesting that the universe is far more complex and interconnected than we ever imagined. Whether they exist or not, white holes remind us that the cosmos is full of mysteries waiting to be uncovered, and that the boundaries of our knowledge are constantly being pushed to new and unsettling frontiers. Now shifting our gaze to a theory that paints a chilling picture of the universe's ultimate fate, we arrive at the Big Rip. Imagine a force so powerful that it doesn't just pull galaxies apart, it tears apart stars, planets, and even the very fabric of matter itself. This is the essence of the Big Rip, a theory that suggests the universe's expansion could accelerate to such an extreme degree that everything, down to the smallest atom, is ripped to shreds. The Big Rip hinges on the behavior of dark energy, the mysterious force driving the universe's accelerated expansion. If dark energy continues to grow stronger over time, it could eventually overpower all other forces in the cosmos: gravity, electromagnetism, even the nuclear forces holding atoms together. The result, a universe where galaxies are torn apart, stars are ripped from their orbits, and planets are reduced to cosmic dust, but it doesn't stop there. As the expansion accelerates, even atoms and subatomic particles would be pulled apart, leaving behind a cold, empty void where nothing can exist. What makes this theory particularly unsettling is its inevitability. If dark energy behaves as some models predict, the Big Rip isn't just a possibility, it's a certainty. Scientists estimate that this catastrophic event could occur in as little as 22 billion years, a blink of an eye on cosmic timescales. The idea that the universe could end not with a whimper but with a violent, all-consuming tear challenges our understanding of existence itself. The Big Rip also raises profound questions about the nature of time and space. If the universe's expansion becomes so extreme that it tears apart the very fabric of reality, what happens to time? Could it stretch and distort or even cease to exist altogether? These are questions that push the boundaries of our knowledge, reminding us that the universe is far stranger and more unpredictable than we often assume. As we contemplate the Big Rip, we're left with a sense of awe and unease. It's a reminder that the cosmos is not a static, unchanging place, but a dynamic and ever-evolving entity. Whether the Big Rip is our ultimate fate or not, it forces us to confront the fragility of existence and the profound mysteries that still lie beyond our understanding. And with that, we turn to the next eerie theory, one that challenges our perception of the universe's origins and the very fabric of reality itself. Now turning to a theory that takes us back to the very beginning of everything, we delve into the mysteries of the cosmic microwave background anomalies. This faint glow of radiation, often called the afterglow of the Big Bang, holds secrets that could rewrite our understanding of the universe's origins. But what if this cosmic fingerprint isn't just a relic of our universe? What if it's a window into something far stranger, like a parallel universe or even a reality that existed before the Big Bang? The cosmic microwave background, or CMB, is the oldest light in the universe, dating back to just 380,000 years after the Big Bang. It's a snapshot of the universe in its infancy, and for decades, scientists have studied it to understand how everything began. But within this ancient light, there are anomalies, strange patterns and irregularities that don't fit our current models. Some researchers believe these anomalies could be evidence of a collision with another universe, one that existed alongside ours in a vast multiverse. Imagine the implications. Our universe might not be alone, but part of an infinite tapestry of realities, each with its own laws of physics. others have proposed an even more mind-bending idea, that these anomalies are remnants of a pre-Big Bang universe. This theory suggests that the Big Bang wasn't the true beginning, but rather a transition from an earlier state of existence. If true, it would mean that our universe is just one chapter in an endless cosmic story, with countless others before and after it. The eerie part, we might never know for sure. These anomalies are like whispers from a time and place beyond our comprehension, hinting at realities that defy our current understanding. What makes these anomalies so unsettling is how they challenge the very foundation of cosmology. If the CMB holds clues to a multiverse or a pre-Big Bang universe, it means our understanding of time, space, and existence is incomplete, or perhaps entirely wrong. It forces us to confront the possibility that the universe is far more complex and mysterious than we've ever imagined. Are we just one of many universes, or is there something even more profound lurking in the shadows of the CMB? As we ponder these questions, we're reminded that the universe is full of surprises. The cosmic microwave background anomalies are a humbling reminder that even our most advanced tools and theories can only scratch the surface of reality. And with that, we move to the next theory, one that explores the eerie possibility that time itself might be trapped in an endless loop. Now shifting our gaze to the fabric of time itself, we encounter the unsettling possibility of the time loop theory. Imagine a universe where every event, every moment, is destined to repeat itself endlessly, like a cosmic record stuck on replay. This theory suggests that time might not be a straight line stretching into infinity, but rather a closed loop where the end circles back to the beginning, trapping everything in an eternal cycle. The implications are as eerie as they are profound. What if every choice you've ever made, every path you've taken, is just a repetition of a past you can't remember? The idea of a cyclical universe isn't entirely new. Ancient philosophies and religions have long pondered the concept of eternal recurrence, where history repeats itself in an infinite loop. But modern science has given this idea a new twist. Some physicists propose that the universe could be governed by laws that allow time to fold back on itself, creating a loop where the Big Bang leads to expansion, contraction, and then another Big Bang over and over again. This cyclical model challenges our linear understanding of time, suggesting that the universe might not have a definitive beginning or end, but instead exists in a perpetual state of renewal. What makes this theory so unsettling is how it forces us to confront questions about free will and destiny. If the universe is stuck in a time loop, are our actions truly our own, or are we simply following a script written by the cosmos? Could every decision we make be predetermined, replaying endlessly in an infinite cycle? The philosophical implications are staggering, blurring the line between choice and inevitability. It's a haunting thought that our lives might be part of a cosmic pattern, repeating endlessly without our knowledge. Scientifically, the time loop theory finds support in certain interpretations of general relativity and quantum mechanics. For instance, closed time-like curves, or CTC, are hypothetical solutions to Einstein's equations that allow for time travel into the past, effectively creating a loop. While these concepts remain speculative, they open the door to the possibility that time might not be as straightforward as we think, the eerie part. If time loops exist, we might never be able to detect them, trapped as we are within the cycle. As we grapple with the idea of a universe caught in an endless loop, we're left to wonder, is time a river flowing in one direction or a circle with no beginning or end? The time loop theory invites us to rethink everything we know about existence, destiny, and the nature of reality itself. And with that, we turn to the next theory, where the very fabric of space-time faces an even more dramatic fate. Now turning to a force that could spell the ultimate end of everything we know, we delve into the chilling concept of phantom energy. Imagine a form of dark energy so powerful, so relentless, that it doesn't just push the universe to expand, it accelerates that expansion to the point of no return. This is the essence of phantom energy, a hypothetical force that could one day tear apart the very fabric of spacetime itself. Unlike ordinary dark energy, which drives the universe's expansion at a steady pace, phantom energy grows stronger over time, threatening to rip apart galaxies, stars, and even the atoms that make up our existence. The idea of phantom energy stems from observations of the universe's accelerating expansion. Scientists have long known that dark energy is responsible for this phenomenon, but phantom energy takes it to an extreme. If it exists, it could cause the universe to expand so rapidly that it overcomes the forces holding matter together. The result, a catastrophic event known as the Big Rip. In this scenario, the universe wouldn't just fade into cold, empty darkness. It would be violently torn apart, leaving nothing but a void where galaxies, planets, and even the smallest particles once existed. What makes this theory so unsettling is the sheer inevitability it suggests. If phantom energy is real, the Big Rip isn't a question of if, but when. Some estimates suggest it could happen in as little as 22 billion years, a blink of an eye on cosmic timescales. The thought of such a violent end challenges our understanding of the universe's fate. Instead of a slow, cold death through heat death or a cyclical rebirth, the universe could face a dramatic, explosive demise. The implications of phantom energy extend beyond the physical destruction of the cosmos. It forces us to confront the fragility of existence itself. If the universe can be torn apart by its own expansion, what does that mean for the laws of physics as we know them? Could the fundamental forces that govern reality be overridden by this mysterious energy? And perhaps most haunting of all, if the Big Rip occurs, would there be any trace left of the universe as we know it, or would it be erased entirely? As we ponder the eerie possibilities of phantom energy, we're reminded of how little we truly understand about the forces shaping our universe. It's a humbling thought that something as invisible and intangible as dark energy could hold the key to the cosmos' ultimate fate. And with that, we turn to the next theory, where the mysteries of the universe grow even darker. Now shifting our gaze to a theory that challenges the very foundation of our existence, we explore the unsettling concept of the Boltzmann universe. Proposed by the physicist Ludwig Boltzmann, this idea suggests that our universe might not be the grand, inevitable outcome of cosmic evolution, but rather a fleeting, random fluctuation in an otherwise chaotic and lifeless void. Imagine a vast, infinite sea of disorder where the laws of physics and the structure of reality are constantly shifting. In this chaotic expanse, the emergence of a stable, ordered universe like ours would be an incredibly rare event, a momentary blip in an endless ocean of randomness. The Boltzmann universe theory forces us to confront the eerie possibility that everything we know, our galaxies, stars, planets, and even our own consciousness, could be nothing more than a temporary anomaly. It's as if the universe we inhabit is a single, improbable bubble of order in a sea of chaos, destined to eventually dissolve back into the void. This raises profound questions about the nature of reality. If our universe is just a random fluctuation, what does that mean for the laws of physics as we understand them? Are they universal truths or simply the rules of this particular cosmic anomaly? What makes this theory so haunting is the implication that our existence might be entirely accidental. If the Boltzmann universe is correct, then the emergence of life, intelligence, and even the ability to ponder these questions could be nothing more than a cosmic coincidence. It challenges our sense of purpose and meaning, suggesting that the universe wasn't designed for us, it just happened to be a place where we could exist for a brief moment in time. This theory also ties into the concept of entropy, the measure of disorder in a system. Boltzmann's work on entropy laid the groundwork for this idea, showing that while the universe tends toward chaos, small pockets of order can arise spontaneously. But these pockets are fleeting, destined to be swallowed by the ever-increasing tide of entropy. In this view, our universe is one such pocket, a rare and temporary island of order in a vast, chaotic ocean. As we grapple with the implications of the Boltzmann universe, we're left with more questions than answers. Is our reality just a random accident, or is there something more fundamental at play? And if our universe is a fleeting anomaly, what does that mean for the future of existence itself? These questions remind us of the profound mysteries that still surround the cosmos and the limits of our understanding. With that, we turn to the next theory, where the mysteries of the universe grow even deeper. Now venturing into the depths of one of the universe's most enigmatic phenomena, we explore the black hole civilization theory. This idea proposes that advanced civilizations might not just survive but thrive within the extreme environment of a black hole. At first glance, this seems impossible. Black holes are known for their immense gravitational pull, where not even light can escape. Yet, some scientists speculate that within the event horizon, the boundary beyond which nothing can return, there could exist regions where life could theoretically flourish. The theory hinges on the concept of the inner structure of a black hole. While the outer layers are chaotic and destructive, certain models suggest that deep inside, there could be stable zones where the laws of physics behave differently. In these regions, an advanced civilization might harness the immense energy of the black hole itself, using it as a power source to sustain their existence. Imagine a society so technologically advanced that they've mastered the ability to live in one of the most hostile environments imaginable, turning what we see as a cosmic death trap into a thriving habitat. But what makes this theory so eerie is the sheer isolation of such a civilization. If they exist within a black hole, they would be completely cut off from the rest of the universe. Communication with them would be impossible, as any signal sent into a black hole would be lost forever. This raises profound questions about the nature of intelligence and survival. Could a civilization evolve to such a level of sophistication that they no longer need to interact with the outside universe? Or would their isolation eventually lead to their demise? The scientific challenges of detecting or communicating with a black hole civilization are immense. Our current understanding of black holes is limited, and the extreme conditions within them make it nearly impossible to gather direct evidence. Even if such a civilization exists, we might never know. This theory forces us to confront the limits of our knowledge and the possibility that the universe harbors forms of life and intelligence far beyond our comprehension. As we ponder the implications of the black hole civilization theory, we're reminded of the vastness and mystery of the cosmos. It challenges us to rethink what we know about life, survival, and the boundaries of possibility. And with that, we turn to the next theory, where the mysteries of the universe grow even more profound. Now shifting our gaze to a theory that blurs the line between life, death, and the infinite possibilities of the multiverse, we delve into the quantum suicide theory. This unsettling idea stems from the many worlds interpretation of quantum mechanics, which suggests that every possible outcome of an event actually occurs, each branching off into its own separate reality. In this framework, the quantum suicide theory proposes that a person's consciousness could, in a sense, cheat death by continuing to exist in alternate realities where they survive, even if they die in others. Imagine a thought experiment. A person is placed in front of a device that has a 50% chance of killing them with each activation. According to classical logic, the odds of survival decrease with each attempt. But the quantum suicide theory flips this on its head. From the perspective of the person's consciousness, they would always find themselves in the reality where they survive, no matter how many times the device is activated. In every other reality, they die, but their consciousness ceases to exist there, leaving them only aware of the reality where they live. This creates the eerie illusion of immortality, where death becomes an experience they never truly encounter. The implications of this theory are deeply unsettling. It challenges our understanding of mortality, suggesting that death might not be the absolute and we perceive it to be. Instead, it raises the possibility that consciousness could persist indefinitely, hopping from one reality to another, always avoiding the finality of death. This leads to profound philosophical questions. What does it mean to die if your consciousness continues elsewhere? Could this theory imply that, from our own perspective, we are effectively immortal? But the quantum suicide theory also forces us to confront the limits of our understanding of reality. It hinges on the idea that the multiverse is infinite, with every possible outcome playing out somewhere. Yet, this raises another chilling question. If every decision creates a new reality, how do we define our identity? Are we the same person across these infinite realities, or do we splinter into countless versions of ourselves, each with their own experiences and fates? As we grapple with these questions, the quantum suicide theory leaves us with more mysteries than answers. It challenges us to rethink not just the nature of life and death, but also the very fabric of reality itself. And with that, we prepare to explore yet another mind-bending theory, where the universe's secrets grow even more profound. Now turning to a theory that stretches the boundaries of our imagination, we explore the eternal inflation theory. This concept suggests that our universe is not alone but rather one of countless bubble universes, each existing within an ever-expanding multiverse. Picture an infinite cosmic foam where each bubble represents a separate universe, complete with its own unique set of physical laws and constants. Some of these universes might be eerily similar to ours, while others could be so alien that they defy comprehension. The idea of eternal inflation stems from the early moments of the Big Bang, when the universe underwent a rapid expansion known as inflation. According to this theory, inflation didn't stop everywhere at once. Instead, it continues in certain regions, creating new bubble universes that branch off from one another. This process could be endless, leading to an infinite multiverse where new universes are constantly being born. The implications of this are staggering. It means that somewhere out there could be a universe where gravity is stronger, light travels slower, or even where time flows backward. But what makes this theory truly unsettling is the possibility of other versions of ourselves existing in these alternate universes. Imagine a version of you who made a different choice at a critical moment in life, leading to an entirely different outcome. In one universe, you might be a celebrated scientist, while in another, you could be living a completely ordinary life. The eternal inflation theory suggests that every possible version of you exists somewhere in the multiverse, each shaped by the unique laws of their respective bubble universe. This raises profound questions about identity and existence. If there are infinite versions of us, does that make our choices less meaningful? Or does it highlight the infinite possibilities that lie within every decision we make? The theory also challenges our understanding of reality itself. If the multiverse is infinite, then everything we can imagine and everything we can't exists somewhere. This includes universes where life as we know it is impossible, as well as those where it thrives in ways we can't even begin to comprehend. As we ponder the eternal inflation theory, we're left with a sense of awe and unease. It forces us to confront the vastness of existence and the limits of our understanding. And with that, we prepare to delve into yet another cosmic mystery, where the universe's secrets grow even more profound. Now shifting our gaze to one of the most perplexing enigmas in modern science, we delve into the mystery of dark matter. This invisible substance makes up roughly 85% of the universe's total mass, yet it remains completely undetectable by conventional means. Unlike stars, planets, or even black holes, dark matter doesn't emit, absorb, or reflect light, making it utterly invisible to our telescopes. Its presence is only inferred through its gravitational effects on the visible universe, such as the way galaxies rotate or how light bends around massive objects in space. The implications of a universe dominated by dark matter are both profound and unsettling. If most of the cosmos is made up of something we can't see or directly measure, what does that say about our understanding of reality? Scientists have proposed various theories to explain dark matter, ranging from exotic particles that interact only through gravity to massive objects like black holes that simply don't emit light. Yet, despite decades of research, its true nature remains elusive. This raises the eerie possibility that dark matter could be something entirely beyond our current comprehension, a form of matter or energy that operates under rules we haven't even discovered yet. What makes this mystery even more intriguing is the role dark matter plays in the structure of the universe. Without it, galaxies wouldn't have enough gravitational pull to hold themselves together, and the cosmos as we know it wouldn't exist. Yet, despite its critical importance, we still don't know what it is. This has led to some truly mind-bending questions. Could dark matter be evidence of a hidden layer of reality, one that operates parallel to our own, or is it a sign that our understanding of physics is fundamentally incomplete? Efforts to uncover the secrets of dark matter are ongoing, with experiments like the Large Hadron Collider and observatories like the James Webb Space Telescope searching for clues. Some scientists are even exploring the possibility that dark matter could interact with itself in ways we haven't yet observed, creating entire dark galaxies or even dark stars. The unsettling truth is that we're only scratching the surface of this cosmic mystery, and the answers we find, or fail to find, could reshape our understanding of the universe. As we ponder the enigma of dark matter, we're reminded of how much of the cosmos remains hidden from us. It's a humbling thought, one that challenges us to keep exploring, questioning, and pushing the boundaries of what we know. And with that, we prepare to uncover yet another layer of the universe's deepest secrets. Now turning to a theory that blurs the line between science and science fiction, we explore the alien megastructure hypothesis. This idea stems from the mysterious dimming patterns observed in distant stars, particularly one known as Tabby's star, or KIC 8462852. Over several years, astronomers noticed that this star's light would dip in irregular, unpredictable ways far more dramatically than what could be explained by planets or other natural phenomena. This led to the startling suggestion that these dimming events might be caused by massive artificial structures, possibly built by an advanced alien civilization. The most famous proposed structure is the Dyson Sphere, a hypothetical megastructure designed to encase a star and capture its energy output. Imagine a civilization so advanced that it could harness the power of an entire star, constructing a network of solar panels or habitats around it. The implications are staggering. If such structures exist, they would represent a level of technological sophistication far beyond anything humanity has achieved. But here's the eerie part. If these civilizations are out there, why haven't we detected more direct evidence of their existence? Detecting alien megastructures is no easy task. The dimming patterns could be caused by natural phenomena, such as swarms of comets or interstellar dust clouds. Even if the structures are artificial, they might be so advanced that they're nearly invisible to our current technology. This raises unsettling questions about our place in the universe. Are we alone, or are we simply too primitive to recognize the signs of civilizations that have mastered the cosmos? The search for alien megastructures continues, with astronomers using advanced telescopes and algorithms to analyze the light from distant stars. Each new discovery, or lack thereof, brings us closer to answering one of humanity's oldest questions: are we alone? The possibility that we might one day find evidence of such structures is both thrilling and humbling. It reminds us that the universe is vast, mysterious, and full of potential for the unimaginable. As we consider the alien megastructure hypothesis, we're left to wonder what other secrets the cosmos might be hiding. Could there be civilizations out there harnessing the power of stars and reshaping entire galaxies? or are these dimming patterns just another cosmic mystery waiting to be solved? Whatever the answer, this theory challenges us to think bigger, to imagine what might be possible in a universe far older and more complex than we can fully comprehend. Now shifting our gaze to the very fabric of existence, we arrive at a theory that challenges our understanding of time itself, the end of time. Imagine a universe where time, the very framework that structures our lives, simply ceases to exist. No seconds ticking by, no days turning into nights, no past or future, just an eternal, unchanging present. This isn't science fiction. It's a genuine scientific possibility that some physicists and philosophers have explored. The idea stems from the concept that time, like space, is a dimension that can be influenced by the universe's expansion and the behavior of dark energy. If dark energy continues to accelerate the universe's expansion, it could eventually stretch space-time so thin that time itself loses its meaning. In this scenario, the universe would reach a state of maximum entropy, where all energy is evenly distributed and no further change is possible. It's a chilling thought, a cosmos frozen in a single, timeless moment where nothing ever happens again. But what does this mean for us? If time were to end, would consciousness persist in some form, or would it simply dissolve into the void? Philosophers have long debated whether time is an objective feature of the universe or a construct of the human mind. If time is merely a mental framework, its end might not erase reality but could fundamentally alter how we perceive it. The implications are profound, raising questions about the nature of existence, free will, and the very essence of what it means to be alive. This theory also forces us to confront the impermanence of everything we know. Stars burn out, galaxies drift apart, and even the flow of time itself may one day stop. It's a humbling reminder of the universe's vastness and the fleeting nature of our place within it. Yet, it also invites us to appreciate the present moment, to find meaning in the here and now, knowing that time, whether finite or infinite, is a precious and mysterious gift. As we ponder the end of time, we're left with more questions than answers. Could the universe truly reach a state where change is impossible? And if so, what would that mean for the future of existence? These questions may seem abstract, but they touch on the deepest mysteries of reality, urging us to look beyond the familiar and embrace the unknown. With this final theory, we close our exploration of the cosmos's eerie secrets, but the journey of discovery is far from over. The universe, in all its strangeness, continues to beckon us to explore, to question, and to wonder. As we bring our journey through these 25 eerie theories to a close, it's impossible not to feel a sense of awe and perhaps a little unease at the vast, mysterious universe we inhabit. From the unsettling possibility that we might be living in a simulation to the chilling idea that time itself could one day cease to exist, each theory challenges our understanding of reality in profound and often unsettling ways. These concepts remind us that the cosmos is far stranger and more complex than we can imagine, filled with mysteries that defy easy explanation. Which of these theories struck you as the most terrifying or plausible? Was it the idea of a universe collapsing into a singularity, or the eerie silence of the Fermi paradox? Perhaps the thought of a multiverse with infinite versions of yourself left you questioning the nature of identity. Whatever your answer, these theories invite us to think deeply about our place in the universe and the endless questions that remain unanswered. If you found this exploration as fascinating as we did, don't forget to hit the like button and share your thoughts in the comments below. Which theory keeps you up at night? Let's keep the conversation going, and if you're hungry for more mind-bending explorations of the cosmos, be sure to subscribe and hit the notification bell so you never miss out on our next deep dive into the unknown. The universe is vast, mysterious, and full of secrets waiting to be uncovered. Together, let's continue to explore, question, and wonder. Thanks for joining us on this journey through the eerie and extraordinary. Until next time, keep looking up and pondering the infinite mysteries of the cosmos.